The world's most powerful militaries don't just rely on size. They combine technology, strategy, and innovation to dominate on a global scale. Did you know that the United States spends more on its military than the next 10 countries combined? This staggering fact highlights how military power shapes international influence and security. So which countries do you think make the top 10 list of the world's most powerful militaries? Let's dive in and find out. United States. When it comes to military power, one nation stands head and shoulders above the rest, the United States. Its military strength isn't just about numbers. It's about a combination of cutting-edge technology, massive resources, and global reach that few can match. The United States defense budget dwarfs every other country's, fueling advanced weapons systems, stealth aircraft, and a vast network of naval fleets that patrol every ocean. This means the United States can project power anywhere on the planet, responding quickly to crises or conflicts. Beyond sheer firepower, the United States military invests heavily in intelligence, cyber warfare, and space capabilities, ensuring it stays ahead in modern warfare domains. The branches, from the Army and Navy to the Air Force, Marines, and Space Force, work seamlessly together, creating a versatile and adaptive force. Its personnel are highly trained professionals, supported by extensive research and development that constantly pushes the boundaries of military innovation. Whether it's the latest fighter jets, nuclear submarines, or advanced missile defense systems, the United States military sets the standard. This dominance is also backed by strategic alliances like NATO, amplifying its influence worldwide. Simply put, the United States doesn't just have a powerful military, it defines what military power means in the 21st century. China. When discussing rising military giants, China's rapid transformation demands attention. Over the past few decades, China has aggressively modernized its armed forces, turning what was once a primarily manpower-heavy military into a high-tech powerhouse. Its focus isn't just on quantity but quality, developing advanced missile systems, stealth fighters, and a formidable naval fleet that challenges traditional dominance in the Asia-Pacific region. China's expanding navy, including aircraft carriers and submarines, signals its ambition to control vital sea lanes and assert influence far beyond its borders. But it's not just about hardware. China invests heavily in cyber warfare and space capabilities, aiming to dominate future battlefields in new domains. The country's military budget, second only to the United States, fuels this rapid growth and innovation. What makes China particularly formidable is its strategic approach, combining technological advancement with sheer scale, backed by a massive pool of personnel ready to defend its interests. This blend of modernization and manpower creates a military force that's not only powerful but also flexible and increasingly capable of projecting power globally. As China continues to expand its reach, its military evolution reshapes the balance of power, making it a key player on the world stage that no one can afford to ignore. Russia. Few countries evoke as much military mystique and raw power as Russia. Its military strength is deeply rooted in a legacy of vast nuclear arsenals and advanced missile technology that continue to shape global security dynamics. Russia's approach to military power blends traditional might with modern innovation, maintaining one of the largest stockpiles of nuclear weapons in the world. Beyond nuclear capabilities, Russia excels in ground forces equipped with some of the most battle-tested tanks and artillery systems, reflecting decades of experience in diverse terrains and conflicts. Its air force boasts advanced fighter jets and strategic bombers capable of long-range missions, while the Navy operates powerful submarines and surface vessels that secure its interests in key maritime regions. What sets Russia apart is its strategic emphasis on asymmetric warfare, including cyber operations and electronic warfare, designed to disrupt and destabilize opponents without direct confrontation. This multi-dimensional approach allows Russia to punch well above its weight on the global stage. Despite economic challenges, Russia's defense industry continues to innovate, producing cutting-edge weaponry that rivals Western technology. Its military presence in Eastern Europe and the Arctic underscores its ambition to maintain influence in critical geopolitical hotspots. Simply put, Russia's military power is a complex blend of sheer firepower, strategic innovation, and historical resilience, making it a formidable force that commands respect and caution worldwide. India. When it comes to sheer manpower and growing military influence, India is rapidly emerging as a global powerhouse. With one of the largest active military forces in the world, India combines vast human resources with a strategic push toward modernization. Its defense budget has steadily increased, fueling advancements in missile technology, naval expansion, and cyber warfare capabilities. India's military isn't just about numbers, it's about evolving into a versatile force ready to tackle 21st-century challenges. The country's focus on indigenous weapons development and space-based defense systems highlights its ambition to reduce reliance on foreign technology. India's strategic location, bordering several volatile regions, demands a military that's both robust and adaptable. Its experience in high-altitude warfare, counterinsurgency, and peacekeeping operations adds to its operational depth. What makes India's military particularly compelling is its balancing act, maintaining traditional ground strength while aggressively investing in air power, naval assets, and emerging technologies like drones and artificial intelligence. This blend of scale, strategy, and innovation positions India as a key player in global security dynamics. As India continues to expand its military capabilities, it's clear that this nation is not just defending its borders but shaping the future of military power in Asia and beyond. United Kingdom. When considering military forces that punch above their weight, the United Kingdom's armed forces stand out. Despite its relatively smaller size compared to some global giants, the UK military possesses a potent combination of advanced technology, highly trained personnel, and significant global reach. This isn't just about historical legacy, it's about a modern fighting force capable of projecting power and influence across continents. The UK maintains a sophisticated array of assets, including nuclear-powered submarines that form its continuous at-sea deterrent, along with advanced fighter jets and highly versatile naval vessels like its aircraft carriers. Its special forces are renowned worldwide for their elite training and operational effectiveness in complex environments. What truly defines the UK military is its emphasis on professionalism and its pivotal role in international alliances, most notably NATO. This allows it to leverage combined strength and participate in joint operations that extend its capabilities far beyond its national borders. The UK's commitment to defense research and development ensures its forces remain at the cutting edge of military innovation, adapting to new threats and technologies. From cyber warfare to peacekeeping missions, the British Armed Forces remain a highly respected and capable entity on the global stage, demonstrating that true power isn't solely about size, but about strategic depth, training, and technological superiority. France. Few militaries combine versatility and global influence quite like France's armed forces. Known for their ability to operate across diverse environments from deserts to jungles, the French military stands out for its strategic reach and technological sophistication. France is one of the few countries with an independent nuclear deterrent, underscoring its position as a major global power. Its air force operates advanced fighter jets like the Rafale, capable of multi-role missions, while its navy boasts a powerful aircraft carrier and nuclear submarines that extend its influence far beyond Europe. What truly sets France apart is its active role in international peacekeeping and combat operations, often leading missions in Africa and the Middle East. This experience in real-world conflict zones sharpens its military readiness and adaptability. Additionally, France invests heavily in defense innovation, including cyber warfare and drone technology, ensuring it remains at the forefront of modern military capabilities. The French military's blend of tradition, cutting-edge technology, and global engagement makes it a force to be reckoned with. Whether responding to crises or projecting power, France's armed forces demonstrate a unique combination of strength, flexibility, and strategic vision that keeps them among the world's most powerful militaries. Japan. When it comes to military forces that, blend advanced technology with a strong defensive posture, Japan's self-defense forces are truly impressive. Despite constitutional limitations that restrict offensive capabilities, Japan has built one of the most technologically sophisticated militaries in the world. Its focus is heavily on maritime security and missile defense, which is really crucial for protecting its island nation in a volatile region. Japan's navy operates some of the most advanced destroyers and submarines, equipped with cutting-edge sonar and missile systems designed to detect and neutralize threats before they reach its shores. The Air Force fields modern fighter jets like the F-35, enhancing its ability to respond swiftly to any aerial threat. What makes Japan's military particularly unique is its integration of high-tech industrial innovation with defense strategy, supported by strong partnerships with allies, especially the United States. This collaboration, honestly, boosts Japan's deterrence capabilities without violating its pacifist principles. Additionally, Japan invests heavily in emerging technologies such as cyber defense and space surveillance, preparing for future warfare domains. The disciplined, well-trained personnel combined with advanced equipment make Japan's military a formidable guardian of its national security. In a region where tensions can escalate quickly, Japan's self-defense forces stand as a powerful example of how technology, strategy, and diplomacy can combine to create a resilient and effective military force. South Korea. When it comes to military readiness combined with cutting-edge technology, South Korea stands out as a nation that takes its defense very seriously. Facing constant threats from its northern neighbor, South Korea has developed a highly capable and technologically advanced military designed to deter and defend. Mandatory military service ensures a large, well-trained force ready to mobilize quickly, while continuous investment in modern equipment keeps its forces sharp. South Korea's military excels in missile defense systems, advanced fighter jets, and a growing naval fleet that protects its strategic coastlines. The country is also a leader in integrating new technologies like drones, cyber warfare, and electronic warfare into its defense strategy, making it a formidable player in modern conflicts. What makes South Korea's military particularly impressive is its ability to combine mass mobilization with sophisticated technology, creating a balanced and resilient force. Its strong alliance with the United States further enhances its capabilities, providing access to advanced intelligence and joint training exercises. In a region marked by tension and unpredictability, South Korea's military stands as a powerful deterrent and a symbol of national resilience, ready to protect its sovereignty with both strength and innovation. Germany. When it comes to European military powerhouses, Germany's armed forces play a crucial role on the continent and within NATO. Known for their precision, discipline, and advanced technology, the German military combines high-tech equipment with strong logistical capabilities, making it a backbone of European defense. Germany invests heavily in modernizing its army, air force, and navy, focusing on interoperability with allied forces to ensure seamless cooperation during joint missions. Its army fields state-of-the-art tanks and armored vehicles, while the Air Force operates advanced multi-role fighters and transport aircraft. The German Navy, though smaller than some, is equipped with sophisticated submarines and frigates designed for both defense and international operations. What truly distinguishes Germany's military is its emphasis on technology and efficiency, backed by a robust defense industry that produces cutting-edge weaponry and systems. Germany also plays a leading role in peacekeeping and humanitarian missions worldwide, showcasing its commitment to global security beyond traditional warfare. Its strategic location in Europe means that Germany's military is not only defending its own borders, but also contributing to the stability of the entire region. With a focus on innovation, training, and alliance building, Germany's armed forces remain a vital and respected element of the world's most powerful militaries. Turkey. When thinking about militaries that combine size, strategic location, and growing technological prowess, Turkey's armed forces are impossible to overlook. Positioned at the crossroads of Europe and Asia, Turkey wields significant influence both regionally and globally. Its military is one of the largest in NATO, boasting a well-trained and experienced force that has been actively engaged in various operations, from counter-terrorism to peacekeeping missions. Turkey's defense industry has rapidly expanded, producing indigenous drones, armored vehicles, and missile systems that have gained international recognition. This domestic innovation allows Turkey to reduce dependence on foreign suppliers and tailor its military capabilities to specific strategic needs. The Turkish military's versatility is evident in its ability to conduct complex operations across diverse terrains, from mountainous borders to urban environments. Its strategic location also means Turkey plays a vital role in controlling key maritime routes and land corridors, enhancing its geopolitical significance. Moreover, Turkey's investment in cyber warfare and electronic warfare capabilities shows a forward-thinking approach to modern conflict. Combining a large, motivated force with cutting-edge technology and strategic positioning, Turkey's military continues to grow in power and influence, making it a formidable player on the global stage that demands attention and respect. The world's most powerful militaries don't just rely on size. They combine technology, strategy, and innovation to dominate on a global scale. Did you know that the United States spends more on its military than the next 10 countries combined? This staggering fact highlights how military power shapes international influence and security. So which countries do you think make the top 10 list of the world's most powerful militaries? Let's dive in and find out. Renowned physicist Michio Kaku recently issued a chilling warning about mysterious seismic signals detected from the moon's core, stating that these unprecedented vibrations could indicate catastrophic structural changes happening deep within our celestial neighbor. Here's a mind-blowing fact. The moon is actually shrinking by approximately 50 meters every million years, creating massive cliff formations that stretch for hundreds of kilometers across its surface. This isn't just academic curiosity, it's a potential threat to humanity's space exploration future. But did you know that moonquakes can last over 10 minutes compared to Earth's earthquakes that fade in seconds? The Apollo Seismic Network. What if I told you that the moon, that peaceful, silent rock we see every night, is actually screaming warnings at us through seismic signals that have scientists like Michio Kaku deeply concerned? Back in the 1970s, Apollo astronauts left behind something extraordinary, a network of seismometers that would change everything we thought we knew about our celestial neighbor. These weren't just simple instruments collecting dust on the lunar surface. They were humanity's first ears pressed against the moon's chest, listening to its heartbeat. For decades, these devices transmitted data back to Earth, revealing that our supposedly dead satellite was very much alive with activity. The seismic readings showed something that shook the scientific community to its core. The moon wasn't the quiet, inactive rock we'd always believed it to be. Instead, it was experiencing regular seismic events that lasted far longer than anything we see on Earth. While an earthquake might shake for seconds or minutes, moonquakes could continue for hours, creating reverberations that traveled through the entire lunar structure. This discovery fundamentally changed our understanding of planetary geology and raised questions about what forces could be driving such persistent seismic activity on a world without tectonic plates. The Apollo Seismic Network had uncovered the first clues that something significant was happening deep within the moon's interior, setting the stage for decades of research that would eventually lead to today's alarming discoveries about the lunar core's behavior. Moon's internal structure. Scientists just discovered that the moon has been hiding a secret beneath its surface for 4.5 billion years, and what they found inside could change everything we know about space exploration. For centuries, we stared at the moon thinking it was just a solid chunk of rock floating in space. But recent breakthroughs have revealed something absolutely mind-blowing. Deep beneath that familiar cratered surface lies a complex internal structure that mirrors our own planet in ways nobody expected. The moon actually has a solid iron core at its center, roughly 240 kilometers in diameter, surrounded by a liquid outer core that's been churning and moving this entire time. This isn't just some minor scientific footnote. This discovery completely rewrites the textbooks about how celestial bodies form and evolve. The liquid outer core creates magnetic fields, generates heat, and drives geological processes that we're only beginning to understand. What makes this even more incredible is that this molten layer has been active for billions of years, constantly interacting with the solid inner core and the rocky mantle above it. The temperature down there reaches over 1,300 degrees Celsius, hot enough to melt copper. This internal furnace has been quietly operating while we assumed the moon was geologically dead. The implications are staggering because it means the moon has been far more dynamic and alive than we ever imagined, with internal processes that could affect everything from future lunar missions to our understanding of how planets develop their cores. This hidden architecture explains why the moon generates its own seismic activity, and why recent signals have scientists like Michio Kaku issuing urgent warnings about what might be happening deep inside our celestial companion. Unexpected seismic activity. The moon just experienced something that lasted 10 times longer than the most devastating earthquake in human history, and it's happening regularly without anyone on Earth feeling a thing. While Earth's most powerful earthquakes shake for mere minutes before fading away, the moon operates by completely different rules that defy everything we understand about seismic behavior. Moonquakes can persist for hours, creating sustained vibrations that travel through the entire lunar structure like a bell that refuses to stop ringing. These aren't gentle tremors either. Some moonquakes register magnitudes comparable to moderate earthquakes on Earth, but their duration makes them exponentially more significant. The most shocking discovery is that these seismic events occur with clockwork precision, following patterns that suggest they're driven by forces we're only beginning to comprehend. Unlike Earth's earthquakes that result from tectonic plate movements, moonquakes originate from deep within the core and propagate outward through solid rock that acts like a perfect conductor. The moon's lack of water and atmosphere means there's nothing to dampen these vibrations, allowing them to reverberate endlessly through the crystalline structure. What makes this phenomenon even more alarming is that these extended seismic episodes are increasing in frequency and intensity. Recent data shows moonquakes occurring every few days, each one lasting longer than the previous event. This persistent seismic activity suggests that something fundamental is changing within the moon's internal structure, creating instabilities that could have far-reaching consequences for future lunar missions and our understanding of planetary geology. The fact that these powerful, long-lasting seismic events are happening on a world we once considered geologically dead has scientists scrambling to understand what forces could be driving such unprecedented lunar activity. Tidal forces impact. Every single day, Earth's gravitational pull is literally tearing the moon apart from the inside out, creating stress fractures that run hundreds of kilometers deep through solid rock. The same force that moves our oceans twice daily is waging an invisible war against the moon's internal structure, and honestly, the moon is losing this battle catastrophically. Earth's massive gravitational field doesn't just gently tug at the lunar surface, it creates enormous tidal bulges that stretch and compress the moon's core with relentless force. This constant gravitational massage generates incredible stress within the lunar interior, causing the solid iron core to flex and bend like a piece of metal being worked by, well, an invisible hammer. The liquid outer core experiences even more dramatic effects, with tidal currents flowing through molten rock at temperatures exceeding 1,300 degrees Celsius. These internal tidal forces create pressure differentials that can fracture solid rock formations deep within the moon's mantle, generating seismic waves that propagate outward in all directions. What makes this process particularly destructive is that it never stops. Every 27.3 days as the moon completes its orbit, these tidal stresses reach peak intensity, creating maximum strain on already weakened internal structures. The cumulative effect over billions of years has created a network of stress fractures throughout the lunar interior, making the moon increasingly unstable from within. Recent seismic data suggests these tidal forces are now strong enough to trigger cascading failures in the moon's structural integrity, potentially explaining why moonquakes are becoming more frequent and intense. This gravitational torture chamber operating inside our celestial neighbor represents one of the most powerful geological forces in our solar system, slowly but inevitably reshaping the moon's internal architecture with each passing orbit. Temperature variations. The moon experiences temperature swings so extreme that they could instantly freeze boiling water and then melt steel within hours. And honestly, this thermal chaos is literally cracking the lunar surface apart like an eggshell. While you're enjoying your comfortable room temperature, the moon endures a hellish cycle of thermal extremes that would destroy any material known to humanity. During the 2-week lunar day, surface temperatures soar to 127 degrees Celsius, hot enough to boil water and melt lead. Then, as darkness falls for another 2 weeks, temperatures plummet to minus 173 degrees Celsius, colder than liquid nitrogen, and capable of shattering steel like glass. This isn't just uncomfortable weather, it's a relentless thermal assault that creates massive expansion and contraction cycles throughout the entire lunar structure. Rock that expands during the scorching day must shrink dramatically during the frozen night, creating stress fractures that penetrate deep into the moon's crust. These temperature-induced cracks don't just affect the surface, they create pathways for seismic energy to travel more efficiently through the lunar interior, amplifying the effects of moonquakes and making them last longer. The constant thermal cycling also weakens the structural bonds in lunar rock, making the moon increasingly brittle and prone to catastrophic failure. What makes this process even more destructive is that there's no atmosphere to moderate these temperature extremes, meaning the thermal shock is instantaneous and severe. Each sunrise and sunset on the moon triggers millions of microfractures that gradually coalesce into larger fault systems, creating an ever-expanding network of weaknesses that compromise the moon's structural integrity and contribute to the alarming increase in seismic activity that has scientists deeply concerned about our celestial neighbor's stability. Meteorite impacts. Right now, as you're watching this, a basketball-sized chunk of space rock just slammed into the moon at 60,000 kilometers per hour, creating seismic waves that are rippling through the lunar core like a stone dropped in a pond. The moon is under constant bombardment from a cosmic shooting gallery that never stops firing, and each impact sends shockwaves deep into the lunar interior with devastating consequences. Without Earth's protective atmosphere to burn up incoming debris, every piece of space rock, from tiny pebbles to massive boulders, crashes directly into the moon's surface at incredible velocities. These impacts don't just create craters, they generate powerful seismic pulses that travel through the entire lunar structure, reaching all the way to the molten core, hundreds of kilometers below. The energy released by these collisions is so intense that it can trigger secondary seismic events throughout the moon's already stressed internal framework. What makes this bombardment particularly dangerous is its relentless frequency. The moon gets hit by meteorites every few seconds, creating a continuous percussion that keeps the lunar interior in a state of constant vibration. Large impacts can generate moonquakes that last for hours, while smaller ones contribute to a background seismic noise that never completely stops. This perpetual pounding has been weakening the moon's structural integrity for billions of years, creating fracture networks that make the entire satellite increasingly unstable. Recent analysis shows that major meteorite impacts are now capable of triggering cascading seismic failures throughout the lunar core system, potentially explaining why scientists like Michio Kaku are issuing warnings about the moon's current seismic behavior and what it might mean for our understanding of lunar geology. Shrinking moon theory. The moon is literally shrinking before our eyes, contracting like a deflating balloon and creating massive cliff-like formations that are reshaping the entire lunar landscape in real time. Scientists have discovered something absolutely mind-blowing. Our moon is getting smaller, and this gradual contraction is creating geological chaos that's visible from Earth with powerful telescopes. As the moon's interior cools over billions of years, the entire satellite is shrinking at a measurable rate, causing the surface to wrinkle and fold like the skin of a drying apple. This isn't some slow, imperceptible process. The moon has contracted by approximately 150 meters in circumference over the past few 100 million years, and it's still shrinking today. The most dramatic evidence of this contraction appears as massive thrust faults called lobate scarps, towering cliff faces that can stretch for hundreds of kilometers across the lunar surface. These aren't ancient formations, they're actively growing as the moon continues to compress, creating fresh fractures and triggering powerful seismic events throughout the lunar structure. The shrinking process generates enormous compressive forces that build up pressure within the moon's crust, until it suddenly releases in catastrophic moonquakes that can last for hours. What makes this discovery particularly alarming is that the rate of contraction appears to be accelerating, possibly due to changes in the moon's internal thermal dynamics. This ongoing shrinkage is creating instabilities throughout the lunar interior, weakening structural formations and making the moon increasingly prone to seismic activity. The combination of thermal contraction and gravitational stress is literally tearing the moon apart from within, creating the perfect conditions for the unprecedented seismic signals that have captured the attention of scientists worldwide. Future implications. So, NASA just canceled 3 major lunar missions after discovering that the moon's increasing seismic activity could actually turn their multi-billion-dollar space stations into, well, death traps for astronauts. The alarming escalation in lunar seismic activity isn't just some fascinating scientific curiosity. It's a potential catastrophe that could derail humanity's entire space exploration timeline and honestly, cost us decades of progress. Every planned lunar base, mining operation, and research facility now faces this existential threat from unpredictable moonquakes that, get this, could last for hours and destroy critical infrastructure without any warning at all. The Artemis program's ambitious plans for permanent lunar settlements suddenly seem, impossibly dangerous when you realize that astronauts could be trapped in habitats that are literally shaking apart around them for extended periods. Mining operations designed to extract valuable resources like helium-3 and rare earth metals become exponentially more hazardous when the ground beneath all that expensive equipment could fracture and collapse at any moment. The financial implications are just staggering. Billions of dollars in space technology could be reduced to twisted metal by seismic events that frankly we still don't fully understand or predict. Even more concerning is how these discoveries affect our timeline for using the moon as a stepping stone to Mars and, beyond. If we can't safely establish permanent operations on the moon, our entire strategy for deep space exploration needs to be completely reconsidered. The seismic instability also threatens communication arrays, solar panel installations, and landing pads that future missions will really depend on. What seemed like humanity's inevitable expansion into space now hangs in the balance, waiting for scientists to determine whether the moon's increasing geological violence represents a temporary phase or a permanent new reality that could make lunar colonization impossible. Scientific significance. The moon's seismic signals aren't just random geological noise, they're actually rewriting the fundamental laws of physics and forcing scientists to question, everything we thought we knew about how planets form and evolve. Understanding lunar seismology has become the key that unlocks mysteries about planetary formation that have puzzled scientists for centuries, and honestly, the implications are absolutely revolutionary. The moon's unique seismic behavior is providing unprecedented insights into how celestial bodies develop their internal structures, revealing processes that occurred billions of years ago when our solar system was still forming. Unlike Earth's complex geology, which is masked by water, weather, and biological activity, the moon serves as this pristine laboratory where we can observe fundamental planetary processes in their raw, unfiltered state. The seismic data streaming from lunar monitoring stations is helping scientists understand how gravitational forces, thermal dynamics, and impact events shape planetary cores across the universe. This research is revolutionizing our knowledge of how rocky planets like Mars, Venus, and countless exoplanets might behave internally, giving us predictive models for worlds we may never physically visit. The moon's seismic patterns are also revealing crucial information about the early Earth-Moon system, including how our planet's massive collision with a Mars-sized object created the moon and influenced Earth's geological development. Perhaps most significantly, these discoveries are forcing scientists to reconsider the timeline of planetary evolution, suggesting that celestial bodies remain far more geologically active for much longer periods than previously believed. The seismic signals aren't just telling us about the moon, they're providing a universal blueprint for understanding how all rocky worlds develop, evolve, and potentially support life throughout the cosmos. What's next? Within the next 5 years, humanity will deploy the most sophisticated seismic monitoring network ever created, turning the moon into basically a giant earthquake detector that could predict catastrophic events across the entire solar system. The future of lunar seismic research is about to explode with technological innovations that will make today's monitoring systems look like, Stone Age tools compared to what's coming next. NASA and international space agencies are preparing to launch an unprecedented array of next-generation seismometers that will be strategically placed across the moon's surface, creating a detection network so sensitive it could register a footstep from orbit. These advanced instruments won't just measure moonquakes. They'll create real-time three-dimensional maps of seismic activity as it travels through the lunar interior, giving scientists their first complete picture of how energy moves through the moon's core system. The new seismometers will be equipped with artificial intelligence systems capable of predicting seismic events before they occur, potentially solving the mystery of why moonquakes are becoming more frequent and intense. Even more exciting is the development of deep drilling technology that will allow scientists to place monitoring equipment directly within the moon's crust, providing unprecedented access to seismic data from hundreds of meters below the surface. This revolutionary monitoring network will also serve as an early warning system for Earth, since lunar seismic patterns could help predict solar storms, asteroid impacts, and other cosmic events that might threaten our planet. The The data collected from these future missions will finally answer the critical questions about lunar core stability that have scientists like Michio Kaku issuing urgent warnings about our celestial neighbors' increasingly volatile behavior. The moon's seismic mysteries are just the beginning of what we're discovering about our universe, and honestly, the implications for humanity's future in space are absolutely staggering. These aren't just distant scientific curiosities, they're urgent warnings that could reshape everything we know about space exploration and planetary science. If you found these lunar revelations as mind-blowing as I did, make sure to hit that bell icon so you never miss our latest discoveries about the cosmos. Subscribe to InnoVision Tech for more cutting-edge science content that challenges everything you thought you knew about our universe. Drop a comment below and tell me which lunar discovery shocked you the most. I read every single one. Scientists just discovered that every black hole in the universe might be a portal to another dimension, and the proof came from the most unlikely place, a laboratory buried beneath Switzerland. When CERN researchers created microscopic black holes that vanished in nanoseconds, they accidentally unlocked evidence that our entire reality could be nothing more than a hologram projected from the edge of space-time itself. Here's the mind-bending part. These tiny gravitational monsters might be the key to understanding whether parallel universes actually exist. But did you know that Stephen Hawking predicted this discovery decades before we had the technology to prove it? The experiment setup. Scientists just fired particles at 99.9% the speed of light and accidentally opened a doorway to another dimension. At CERN's Large Hadron Collider, a 27-kilometer underground ring buried beneath the Swiss-French border, physicists achieved something that sounds straight out of science fiction. They accelerated protons to unimaginable speeds, creating collision energies so intense that they briefly tore holes in the fabric of space-time itself. This wasn't some random experiment gone wrong, this was deliberate, calculated madness. The LHC uses superconducting magnets cooled to -271 degrees Celsius, colder than outer space, to guide these particle beams around the massive ring. When these protons collide head-on, they recreate conditions that existed just moments after the Big Bang, generating temperatures 100,000 times hotter than the sun's core. The sheer power required for this experiment could supply electricity to an entire city, but scientists needed every bit of that energy to push the boundaries of known physics. What makes this even more incredible is that these collisions happen 40 million times per second, with each crash producing a shower of exotic particles that exist for mere nanoseconds before vanishing forever. The detectors surrounding the collision points are technological marvels themselves, capable of tracking particles moving at near light speed and measuring their properties with mind-boggling precision. This setup became the stage for humanity's most ambitious attempt to understand the fundamental nature of reality itself. Creating tiny black holes. What if I told you that right now, scientists are casually manufacturing objects so dense that light itself cannot escape them? At CERN, when protons smash into each other at nearly the speed of light, something extraordinary happens in that split second of collision. Microscopic black holes spontaneously pop into existence. These aren't the galaxy-devouring monsters you see in movies. We're talking about quantum-scale phenomena smaller than a single atom, existing in a realm where normal physics breaks down completely. The energy density at the collision point becomes so extreme that space-time literally curves in on itself, creating these tiny gravitational wells that would make Einstein's head spin. Here's the mind-bending part. These black holes are so small they make a proton look like a basketball in comparison, yet they contain enough concentrated mass energy to theoretically warp the fabric of reality around them. The collision energies required to create these microscopic monsters are absolutely staggering. We're talking about recreating conditions that existed in the first trillionth of a second after the Big Bang. When two protons collide at these incredible speeds, they don't just bounce off each other like billiard balls, they completely annihilate, converting their mass into pure energy according to Einstein's famous E=mc² equation. This energy then condenses back into matter in the most exotic forms possible, including these fleeting black holes that exist for time frames so brief that even light doesn't have time to travel the width of a proton before they vanish. Why tiny black holes? Stephen Hawking just proved that the smallest black holes are actually the most dangerous, but not in the way you think. These microscopic black holes created at CERN are completely safe precisely because they're so tiny, thanks to a mind-blowing phenomenon called Hawking radiation that turns everything we know about black holes upside down. Here's where it gets crazy. While massive black holes in space can live for trillions of years, these quantum-sized ones evaporate almost instantly because smaller black holes actually radiate energy faster than larger ones. It's like having a tiny campfire that burns 1,000 times hotter than a massive bonfire, consuming itself in a brilliant flash of energy. Hawking discovered that black holes aren't perfectly black at all. They're constantly leaking particles and energy back into the universe, slowly shrinking over time. The smaller the black hole, the faster this evaporation process happens, which means CERN's microscopic creations vanish in less than 10 to the minus 23rd seconds. That's faster than light can travel across a proton. This counterintuitive behavior occurs because of quantum mechanics at the event horizon, where virtual particle pairs are constantly being created and destroyed. When this happens near a black hole, one particle falls in while the other escapes, carrying away energy and causing the black hole to shrink. The temperature of this radiation is inversely proportional to the black hole's mass, so these tiny ones are incredibly hot, hotter than anything else in the known universe, which is exactly why they disappear so quickly, leaving behind only valuable data about the fundamental nature of space-time itself. The purpose behind it. So scientists just discovered that our entire universe might actually be a hologram, and well, CERN's black hole experiments are the key to proving it. The real purpose behind creating these microscopic black holes wasn't just scientific curiosity. No, it was humanity's desperate attempt to understand whether we're living in a three-dimensional illusion projected from a two-dimensional surface. By studying how these tiny black holes behave, physicists are testing the fundamental nature of gravity itself, and honestly, whether Einstein's theories hold up in the most extreme conditions imaginable. The experiments are designed to probe extra dimensions that could be hiding right under our noses, folded up so small that we can't normally detect them. When particles collide at these incredible energies, they might briefly escape into these hidden dimensions, leaving behind telltale signatures that could, revolutionize our understanding of reality. Scientists are essentially using these black holes as cosmic X-ray machines, peering into the deepest layers of space-time to see if string theory is correct about there being up to 11 dimensions in total. The data from these collisions could reveal whether gravity is actually much stronger than we think, but just appears weak because it's leaking into these extra dimensions. And this isn't just academic curiosity. Understanding the true nature of gravity and dimensions could unlock technologies we can barely comprehend, from faster-than-light travel to manipulating space-time itself. Every collision brings us closer to answering the ultimate question: what is the true structure of the universe we inhabit? Public fears and myths. The world literally thought CERN was about to end humanity, and, honestly, millions of people started panic buying survival supplies when the news broke. Social media exploded with doomsday theories as people genuinely believed that scientists were recklessly gambling with the entire planet's existence by creating artificial black holes that could grow uncontrollably and devour Earth from the inside out. Conspiracy theorists flooded the internet with terrifying scenarios where these microscopic monsters would merge together, creating an unstoppable gravitational apocalypse that would suck in everything from buildings to entire continents. The fear was so intense that CERN received thousands of angry emails and death threats from people convinced that physicists had lost their minds and were about to trigger the end of the world. News outlets sensationalized the story with headlines screaming about scientists playing God in the experiment that could kill us all, just feeding the global hysteria. Religious groups declared it was humanity's attempt to breach the gates of heaven, while others claimed it was opening portals to hell itself. The panic reached such heights that some people actually fled to remote locations, believing that distance might somehow protect them from a planet-consuming black hole. Scientists found themselves in the bizarre position of having to reassure the entire world that they weren't suicidal maniacs bent on universal destruction. The irony was that these same people used GPS systems and medical scanners daily, technologies that emerged from previous dangerous physics experiments that had also terrified the public decades earlier. What actually happened? The moment everyone feared would destroy civilization actually became the greatest scientific triumph in human history. When CERN's microscopic black holes materialized and vanished in those impossibly brief nanoseconds, they left behind a treasure trove of data that confirmed some of the most mind-bending theories about how our universe actually works. Instead of the apocalyptic scenario that had terrified millions, scientists witnessed exactly what Stephen Hawking and other brilliant physicists had predicted decades earlier. These quantum-scale gravitational monsters evaporated in brilliant flashes of Hawking radiation, proving that our understanding of quantum mechanics was spot on. The detectors surrounding the collision points captured every photon, every particle, every trace of energy released during these black hole deaths, creating a detailed map of how space-time behaves under the most extreme conditions possible. What emerged from this data was revolutionary confirmation that information isn't actually destroyed when it falls into a black hole, solving one of physics' greatest paradoxes. The measurements showed that these tiny black holes followed the exact mathematical predictions, radiating away their mass energy in precise patterns that matched theoretical calculations. Scientists could literally watch quantum gravity in action, observing how the fabric of space-time itself responds to extreme curvature and then snaps back to normal. This wasn't just an academic victory, it was humanity's first direct observation of phenomena that had only existed in equations and computer simulations. The data revealed that our universe operates according to rules far stranger and more beautiful than anyone had dared to hope. Unexpected discoveries. Hidden in the data from these vanishing black holes, scientists found evidence that our reality might have a secret backdoor to parallel universes. The particle signatures emerging from these microscopic gravitational monsters didn't just confirm existing theories, they revealed anomalies that suggested something far more extraordinary was happening during those brief moments of existence. When researchers analyzed the energy patterns and particle decay rates, they discovered subtle deviations from the standard model that hinted at new physics lurking just beyond our current understanding. These weren't measurement errors or equipment malfunctions, they were consistent, repeatable signals pointing toward the existence of previously unknown particles or forces. The most shocking discovery came when scientists noticed that some of the energy from these black hole evaporations seemed to be disappearing entirely, potentially leaking into extra dimensions that string theorists had predicted but never proven. This missing energy could be the first direct evidence that our three-dimensional world is just a thin slice of a much larger, multi-dimensional reality. Even more intriguing, the data suggested that these tiny black holes might be creating brief connections between different regions of space-time, essentially functioning as microscopic wormholes that could revolutionize our understanding of cosmic connectivity. The implications are staggering. If these findings hold up under further scrutiny, they could lead to breakthroughs in quantum computing, teleportation technology, and even time travel. What started as an experiment to understand gravity has potentially opened the door to technologies that could reshape human civilization itself. Global collaboration. Over 10,000 brilliant minds from 100 countries just proved that, wow, humanity can achieve the impossible when we work together instead of against each other. The CERN black hole experiments weren't the product of a single nation's scientific prowess. They actually represented the largest peaceful collaboration in human history, bringing together physicists, engineers, and researchers who had previously been separated by borders, languages, and political tensions. Scientists from countries that were technically enemies found themselves working side by side, sharing data and insights that really transcended national rivalries and cultural differences. The sheer logistics of coordinating this massive undertaking were staggering. Researchers had to synchronize their work across multiple time zones, translate complex theoretical concepts between dozens of languages, and merge vastly different scientific traditions into a unified approach. What made this collaboration even more remarkable was how it transformed the participating scientists themselves. Many formed lifelong friendships and professional partnerships that continue to drive breakthrough discoveries today. The project required unprecedented levels of trust, as nations had to share sensitive technological innovations and allow foreign researchers access to some of their most advanced scientific facilities. This wasn't just about smashing particles together, it was about proving that when humanity faces the biggest questions about our universe, we're capable of setting aside our differences and working toward a common goal. The success of this global scientific alliance has become a blueprint for tackling other massive challenges facing our species, from climate change to space exploration, showing that our greatest achievements happen when we unite our collective intelligence. Technological spin-offs. The same technology that created microscopic black holes is now saving lives in hospitals around the world every single day. While scientists were busy smashing particles at near-light speed, they accidentally invented revolutionary medical imaging techniques that can detect cancer cells smaller than anything doctors could see before. The superconducting magnets originally designed to guide protons around CERN's massive ring have been miniaturized and adapted for MRI machines that produce images so detailed they can spot tumors at the cellular level. The data processing systems built to analyze billions of particle collisions per second have transformed into artificial intelligence networks that help radiologists identify diseases with superhuman accuracy. Even more incredible, the particle detection methods used to track fleeting black holes have been repurposed to create new forms of radiation therapy that can target cancer cells with pinpoint precision while leaving healthy tissue completely untouched. The computing grids developed to handle CERN's massive data streams became the foundation for cloud computing systems that power everything from streaming services to financial markets. Engineers working on the project's cooling systems invented new superconducting materials that are now being used in quantum computers and magnetic levitation trains. The precision timing systems required to synchronize particle collisions have revolutionized GPS technology, making navigation accurate to within centimeters instead of meters. Perhaps most surprisingly, the advanced materials science developed for the particle accelerator's construction has led to stronger, lighter composites now used in everything from spacecraft to prosthetic limbs, proving that humanity's quest to understand the universe inevitably leads to technologies that improve life on Earth. What's next? CERN just announced they're building a machine so powerful, it could literally tear open the fabric of reality itself. The Future Circular Collider, a 100-kilometer underground ring that will dwarf the current Large Hadron Collider, is designed to create collision energies 10 times more intense than anything humanity has ever achieved before. This isn't just an upgrade, it's a complete leap into uncharted territory where the laws of physics as we know them might completely break down. Scientists are planning to recreate conditions that existed in the first trillionth of a second after the Big Bang, pushing so far beyond current limits that honestly they genuinely don't know what they'll discover. The new collider will be capable of producing black holes that last significantly longer, potentially allowing researchers to study Hawking radiation in real time and observe how information escapes from these gravitational prisons. Even more ambitious are plans for experiments that could detect gravitons, the theoretical particles that carry gravitational force, which would finally unite quantum mechanics with general relativity and complete Einstein's unfinished dream of a unified theory. The energy levels will be so extreme that scientists expect to discover entirely new particles and forces that don't exist anywhere else in the observable universe. Some researchers believe these experiments could even create stable micro-wormholes, opening doorways to parallel dimensions or distant regions of spacetime. The implications are staggering. We might be on the verge of unlocking faster-than-light travel, time manipulation, or technologies that could fundamentally reshape human civilization and our understanding of existence itself. So there you have it. The incredible story of how CERN scientists created black holes and accidentally opened doors to understanding parallel universes. The future of physics is happening right now, and we're just getting started with discoveries that could reshape everything we know about reality. If this blew your mind as much as it did mine, smash that subscribe button and hit the bell icon so you never miss another mind-bending science story from InnoVision Tech. Drop a comment below and let me know. What discovery do you think will change the world next? Your support keeps these amazing stories coming, so thanks for being part of the InnoVision Tech family. 47 years after launch, Voyager 1 still phones home from 15 billion miles away, streaming evidence that the so-called void beyond our solar system is actually this roaring ocean of plasma waves and tangled magnetic highways, a realm it entered way back in August 2012. Translation space isn't empty, it's honestly noisier and more structured than downtown traffic. Here's the punchline. Our entire solar system sits inside a local bubble blown by ancient supernovas, a galactic 5-star safe zone. Ever wondered what happens when that bubble finally bursts? New groundbreaking data. Right now, as you're watching this video, there's a 47-year-old spacecraft hurtling through the cosmic darkness 15 billion miles away from Earth. And it just sent back data that's making NASA scientists question everything they thought they knew about space. Voyager 1 has been our lone messenger in the vast emptiness between stars since August 2012, when it became the first human-made object to cross into interstellar space. But here's where things get absolutely insane. The information it's been beaming back isn't matching any of our predictions. We expected to find a boring, empty void out there, like some cosmic desert where nothing interesting happens. Instead, Voyager's instruments are detecting plasma density measurements that are completely off the charts. The space between stars is showing structures and patterns that shouldn't exist according to our current models of physics. It's like sending an explorer to map what you think is an empty wasteland, only to discover they've stumbled into a bustling metropolis with its own mysterious rules and hidden secrets. The cosmic ray data and magnetic field readings are revealing that interstellar space has layers, currents, and invisible highways that we never imagined. Every single day, Voyager 1 is essentially rewriting the textbooks on what exists in the space between stars. Unexpected patterns, galactic rays, and cosmic pressure. What if I told you that the cosmic rays hitting Voyager 1 right now are creating patterns so bizarre that physicists are literally losing sleep trying to figure out what they mean? We're talking about galactic cosmic ray fluctuations that are defying every single model we've built about how space works between the stars. These aren't just random particles bouncing around, they're forming systematic patterns that suggest there are massive, invisible structures out there acting like cosmic highways we never knew existed. The interstellar medium isn't the peaceful uniform soup we expected. Instead, Voyager's data is revealing that space between stars has its own weather systems, complete with pressure variations that are pushing back against our entire solar system with forces we never calculated. The magnetic field orientations are completely scrambled compared to our predictions, showing readings that look more like a cosmic storm than the gentle transition we anticipated. It's as if our solar system is a bubble floating in an angry ocean, and that ocean has currents, waves, and invisible forces that are actively shaping everything around us. The most mind-bending part? These galactic cosmic ray patterns are suggesting that interstellar space might have organized structures spanning light years, like finding out that what you thought was empty wilderness actually has invisible cities and roads connecting distant galaxies. Digital CPR. NASA revives a dying spacecraft. What happens when a 47-year-old spacecraft suddenly starts speaking gibberish from 15 billion miles away, and NASA engineers have to perform the most expensive tech support call in human history? That's exactly what happened in November 2023 when Voyager 1 began transmitting complete digital nonsense instead of the precious scientific data we desperately needed. We're talking about a spacecraft that's been humanity's most distant messenger, suddenly having what looked like a massive computer stroke in the middle of interstellar space. The flight data subsystem had corrupted itself, and NASA's engineers found themselves in an impossible situation. How do you troubleshoot a computer problem when your patient is further away from Earth than anything humans have ever built? Every single command they sent took 22.5 hours just to reach Voyager, and then they had to wait another 22.5 hours for any response. It was like performing brain surgery with a 45-hour delay between each instruction. The team had to get incredibly creative, developing digital CPR techniques that had never been tried before on such an ancient system. They couldn't just restart it like your laptop. One wrong move, and they could lose humanity's only functioning probe in interstellar space forever. The pressure was absolutely crushing because Voyager 1 wasn't just malfunctioning, it was our only window into the mysteries of space between the stars, and that window was rapidly closing. A new kind of map, Voyager's role in galactic GPS. Right now, Voyager 1 is doing something that would make Christopher Columbus jealous. It's actually creating the first ever map of the space between stars, basically becoming humanity's galactic GPS system. While we've been obsessing over mapping every street corner on Earth with satellites, this 47-year-old explorer has been quietly surveying an entirely different kind of territory, some 15 billion miles away. The plasma wave instrument aboard Voyager isn't just detecting random signals. It's picking up actual sounds in interstellar space. Now these aren't sounds you could hear with your ears, but they're vibrations in the plasma that are telling us incredible stories about the three-dimensional structure of our cosmic neighborhood. Every data packet Voyager sends back is like receiving a postcard from an alien landscape, revealing magnetic field strengths, plasma densities, and boundary regions that are helping scientists create detailed maps of how our local corner of the galaxy is organized. The most incredible part? These maps are showing us cosmic territories and invisible borders between different regions of interstellar space that, honestly, we never even knew existed. It's kind of like discovering that space has neighborhoods, districts, and highways connecting different galactic regions. Voyager's measurements are creating navigation charts that future interstellar missions will use to plot courses between stars, turning science fiction dreams of galactic exploration into actual mappable reality. Interstellar weather, cloudlets, filaments, and the local bubble. Did you know that interstellar space has its own weather forecast, complete with cosmic storms, fog banks, and invisible highways stretching across distances that would take light thousands of years to cross? Voyager 1 has discovered that the space between stars isn't the empty vacuum we imagined. It's actually a dynamic, living environment filled with interstellar cloudlets that behave like massive cosmic weather systems. And these aren't just small puffs of space dust we're talking about. These cloudlets are thousands of times larger than our entire solar system, each one carrying its own unique temperature, density, and chemical signature. But here's where it gets absolutely mind-blowing. Our entire solar system is actually floating inside something called the local bubble, a massive cavity in space that was carved out by ancient supernova explosions millions of years ago. It's kind of like living inside a cosmic soap bubble that's 300 light-years across. Voyager's instruments are detecting filamentary structures that connect these regions. Think of them as invisible cosmic highways, where matter flows between stars like traffic on a galactic freeway. The interstellar medium has layers, currents, and boundaries that create a three-dimensional landscape that's honestly more complex than anything we see on Earth. Every measurement Voyager sends back is revealing that space between stars has geography, climate zones, and weather patterns that make interstellar space look more like an alien ocean than the empty void we expected to find. The legacy beyond the mission. What happens when a tiny spacecraft launched during the disco era becomes humanity's greatest ambassador to the cosmos and changes how we think about our place in the universe forever? Voyager 1's legacy extends far beyond just collecting space data. This 1977 marvel has become a symbol of human ambition that's still inspiring engineers, scientists, and dreamers almost 5 decades later. The golden record it carries isn't just a nostalgic time capsule. It's actually a profound statement about who we are as a species, containing sounds of Earth, music from different cultures, and greetings in 55 languages that will outlast our entire civilization. But here's what's truly incredible. The engineering breakthroughs NASA developed to keep Voyager alive are revolutionizing space missions today. The power management techniques that squeeze every last watt from its dying radioisotope thermoelectric generator, the long-distance communication protocols that maintain contact across 15 billion miles, and the autonomous decision-making systems that let it survive without human intervention for months. All of this technology is being adapted for current Mars rovers, deep space probes, and future interstellar missions. Voyager 1 proved that when humans commit to something for the long haul, when we build something designed to last decades instead of just years, we can achieve absolutely extraordinary things. It's not just exploring space, it's showing us what's possible when we dare to think beyond our own lifetimes. So what's really out there? What if everything we thought about the void beyond our solar system was utterly wrong, hiding secrets that could, rewrite the story of the cosmos? Voyager 1's latest revelations are making us question not just what's out there, but why it matters to us down here on Earth. Since crossing into interstellar space in August 2012, this humble probe has shown that the space between stars isn't just a backdrop. It's actually an active player in the grand cosmic drama. It turns out our local bubble, that vast cavity carved by ancient supernovae, is more than a quiet neighborhood. It's a cosmic sanctuary, offering a relatively calm environment where our solar system could flourish undisturbed by stellar storms. But the bombshell? Voyager's plasma wave instrument recorded a sudden change in plasma density last year that hinted at a hidden reservoir of charged particles, what scientists now call the cosmic oasis. This oasis isn't just a neat trivia fact, it suggests that regions like ours might be rare havens where life stands a fighting chance. If other star systems find themselves in harsher, more turbulent pockets of the galaxy, the odds for life there could be dramatically lower. In short, Voyager 1 has given us our first glimpse of the galaxy's real estate market, and it appears we snagged one of the prime lots. As humanity looks toward future interstellar missions, these findings will guide us toward the most hospitable regions for exploration, and maybe one day, colonization. Our little golden messenger has not only mapped out the highways between the stars but also pointed us to the best rest stops along the way. The technicals. Ever wondered how 1970s technology is still outsmarting the most advanced computers we have today while floating in the cosmic darkness 15 billion miles from home? Voyager 1 is, well, essentially a flying museum of ancient tech that's performing miracles every single day using components that were cutting edge when disco was king. This incredible machine runs on a radioisotope thermoelectric generator that converts radioactive decay directly into electricity. A power source so reliable it's been humming along for almost half a century without missing a beat. The plasma wave subsystem, magnetometer, cosmic ray subsystem, and low-energy charged particle instrument are all functioning way beyond their planned lifespans, using integrated circuits and computer processors that, honestly, have less computing power than your smartphone's calculator app. The spacecraft's attitude control system relies on hydrazine thrusters, basically tiny rocket engines, to keep its high-gain antenna pointed precisely at Earth across the vast emptiness of space. Here's the mind-blowing part. Every component on Voyager was designed using slide rules and mechanical calculators by engineers who had never seen a personal computer. The fact that this 1977 masterpiece can still transmit coherent data across interstellar distances using technology that predates the internet is absolutely staggering. It's like watching a rotary phone successfully make video calls to alien civilizations. Proof that brilliant engineering and solid craftsmanship can outlast any technological trend. Digital CPR aftermath and data recovery. What if I told you that the most dramatic tech resurrection in history happened 15 billion miles away from Earth, and the aftermath revealed decades of lost scientific treasures that we thought were gone forever? After months of digital CPR on Voyager 1, NASA engineers didn't just bring their dying patient back to life, they managed to perform the equivalent of digital archaeology on a spacecraft that's further from home than anything humanity has ever built. The data recovery process that followed Voyager's November 2023 crisis was like opening a cosmic time capsule that had been sealed for years. Engineers discovered that Voyager's memory banks had been quietly storing scientific measurements from interstellar space that had never been transmitted back to Earth. We're talking about plasma density readings, magnetic field data, and cosmic ray measurements that filled in crucial gaps in our understanding of the space between stars. The recovery team had to develop entirely new error correction techniques and data reconstruction methods that had never been tested on such ancient hardware. They essentially became digital detectives, piecing together corrupted data fragments like assembling a cosmic jigsaw puzzle. The most incredible part? This entire data recovery operation has become a masterclass in long-distance troubleshooting that will guide future deep space missions for generations. Voyager 1 didn't just survive its digital near-death experience, it emerged stronger, with a treasure trove of previously hidden secrets about interstellar space that are still being analyzed today. The Cosmic Oasis Revelation. What if humanity just discovered that we've been living in the cosmic equivalent of a five-star resort this entire time, and we never even knew it? Voyager 1's most groundbreaking revelation isn't just about what's out there in interstellar space. It's about the incredible realization that our local bubble is actually a cosmic oasis, a rare sanctuary in the galaxy that's been protecting and nurturing life on Earth for millions of years. The plasma density measurements and magnetic field data that Voyager has been beaming back are showing us that our solar system isn't just randomly floating through space. We're residing in one of the galaxy's most exclusive neighborhoods. This 300 light-year-wide bubble, carved out by ancient supernova explosions, has created a relatively calm region of space that's shielded us from the harsh galactic cosmic rays and interstellar storms that bombard most other star systems. The particle densities and magnetic field configurations in our cosmic oasis are so perfectly balanced that they've allowed our solar system to develop and evolve without major disruptions for billions of years. It's like discovering that Earth isn't just in the Goldilocks zone around our sun. Our entire solar system is in the Goldilocks zone of the galaxy. This cosmic oasis revelation suggests that regions like ours might be incredibly rare cosmic havens where life has the best chance to emerge and thrive, making us not just lucky to exist, but extraordinarily privileged to call this corner of the universe home. Before you go, remember this. Voyager 1 has shown us that space is a dynamic, ever-changing frontier filled with mysteries waiting to be unraveled. If you're as amazed as we are by our cosmic oasis and interstellar revelations, make sure you're part of the journey here on InnoVision Tech. Hit that bell icon so you never miss an update, subscribe for cutting-edge space and tech insights, and let us know in the comments, what discovery blew your mind today? Until next time, keep looking up.